Okay, start our next lesson. It is a lecture lesson today, and we continue to discuss information about supply chains and about logistic, different types of flow, and how we could to change something in delivery process and optimize this system. Okay, now I share my screen with our distance course on platform of Moodle. Yes. So it is today now our next lecture number 11 about prognostication. It is information about our practical lessons. We already finished it. We discussed this information about different types of prognosis, how we could use it in different types of company and others. So I think it will be interesting today. I adding home, maybe it will be better. So lecture number 11, it is about prognostication, general principles of forecasting. So today we start to discuss about different types of prognosis, and we discuss about positive and negative parts of different types of prognosis, and we discuss about how is better to prognostication in our company, transport company, and other manufacturing company and other systems. So, forecasts serve as a source of information flow that fits the system of planning and coordination in logistics. A forecast is a prediction of the cost value or number of units of a product that is likely to be produced, shipped, or sold. It is possible to forecast in kind or monetary units of measurement, and the object of the forecast can be a specific product or consumer or some group of product and consumers. So we used this type of activity in every activity of different types of company. An accurate forecast allows managers to prevent the occurrence of bottlenecks and tension in demand for capacity and inventory in advance. The forecast of logistics needs dictates the structure of product distribution between distribution centers, wholesale-based, and an even greater extent retail stores, for example. Forecasting improvement logistics efficiency because it creates opportunities for sharing information rather than inventory. In the calculation, it should be taken into account that the demand at each J's level. Oh, yeah, I think you remember from our practical lessons, we discuss about different levels. For example, it could be local shop, it could be some warehouses, it could be some manufacturer, for example, and we discuss that it is some levels. And now in lecture materials, we could use letter J as the number of different types of levels. J's level is equal to the purchase level at the previous J minus 1. It is upper level. For example, if we discuss about local shop and warehouse, local shop is upper level and warehouse is next level after it. So the opening stock corresponds to the closing stock in the previous I minus 1 week. If we discuss about week, we write that every week is we write this as letter I, for example, because it could be 1 week, 2 week, 3 week, and for some variants on our practical lessons, it was near 6 week. For some variants, it was 8 week. For some variants, it was 12 week. It is the biggest part for our periods when everything will start and everything we got to discuss. So about if we say about weeks, we say about I. If we say about level, we say about J. So the engine inventory at each level corresponds to the expected demand at the same level. In the first week, everything goes as usual. That is 100 units of goods. For example, if we discuss about different types of products, for example, in our practical lessons, we had example about mobile phones. So we could continue here and discuss that we have demand 100 mobile phones, for example, or it is about pairs of shoes here. Okay, let's discuss about 100 pairs of shoes we could buy in a local shop every week. For example, we have such type of demand, and we discuss how it will be if something change in some weeks. For example, somebody buy new shoes and this demand change for this local shop. So, continue, please. That is, then in the second week, for example, customer demand increases to 105 units. So it start to be bigger, and to meet this demand, the retail Warsaw's must buy 105 units. For example, pushes an additional 5 units and increase its ending inventory to 105 units. So he buys 110 units from the local warehouses. Why? I remember you because we already discussed it on practical lessons that our local shops think that we need more products because customers need more these shoes, for example. So they buy more on the next week and wait the bigger demand. But sometimes it couldn't be possible, so we need to think more creativity and about used different types of prognosis. So the local sailor must supply 110 units and have an additional 10 units to increase its ending inventory to 110 units. So he buys 120 units from the regional wholesaler. So we have, for example, a wholesaler, local wholesaler, and we have the next level, it is regional wholesaler. So we, it could be more levels or less levels. It is different situation. So we discuss about, for example, it is and regional wholesaler also. The regional wholesaler should supply 120 units and increase its ending inventory by 20 units, bringing it to 120 units. Therefore, he buys 140 units from the manufacturers. So in the manufacturers, they need to produce more shoes, for example, this week, and they plan that next week they need more and more shoes. But it couldn't be possible every week. So in the third week, the reverse effect is observed when consumer demand returned to 100 units. For example, the retailer now reduced its ending inventory to 100 units, so it needs to buy 80 units from the regional wholesalers because they think that we don't need so much shoes, for example, yes, and we need to think about it. A regional wholesaler reduced its ending inventory by 40 units, resulting in each buying only 40 units from the manufacturer. A manufacturer would like to reduce its end-of-week inventory by 100 units, but demand is only 40 units, so it stops production and meets all demand from inventory. Sometimes for manufacturer it could be such situation, then we don't need to produce something and it happened some weeks by this type of prognosis. In the fourth week, we continue. In the fourth week, the manufacturer had to produce 220 units. On the fifth 260, on the 6th 25, and continue then on the 7th 260. Be careful because we nothing doing some weeks, and after it we're doing a little bit shows, and on the 7th week we produce 260 shoes. So it is very, very big. It is more than twice more in 2.5. So it is very big part of shoes. And in the H week, for example, zero shoes again. So we have such situation. Thus, periodic fluctuations is demand of only 5% once a month forces the manufacturer to continually change the volume of products produced. In turn, this affects the number of employees. And the effect of this is observed for the next few weeks at all levels logistics change. This example shows that due to the weakness of information support, each area of activity is forced to rely on its own forecast. But the improvement of information technologies and the need to reduce stocks are pushing for the integration of forecasts both at the level of individual firms and throughout the supply chains. The task of forecasting is to predict spatial. We need to think about type of products, and we discuss about products that goods that don't need some specific cold or hot temperature or something else. So we also think about this predict special. And assortment, of course, how much and what we need and when we need, because different local shops has different demand, and sometimes we need to think about the location also. And temporal when parameters of demand for planning based on their logistics activities. So logistics needs quantitative forecast of demand for planning and coordination of individual operation. Forecast, as a rule, are made for months or a week in relation to each storage unit, for example, goods item, and to each distribution center. The actual estimate consists of 6 elements. I hope you remember from our practical lessons these 6 elements. It is basic demands, it is seasonal factor, time trend, it is cyclical factor, effect of sales stimulation, and random fluctuations. So sometimes we need to discuss about, to think, and in our calculation we need to calculate all these 6 elements in our calculation for prognostication. Base demand is the average value of demand for the period. So the seasonal factor is manifested in the periodical increase and decrease of demand during the year. An example is the spike in demand for toys in Christmas, sometimes in Christmas holidays, and we know that more these products and demand will be very high. So yes, we really need more products, more toys for this period of the year. It is really season factor, and we need to think about it in different months during the year. If with relatively low demand in the other 3 quarters. So after it, it wasn't very big demand every year. So we need to think about it in future and prepare for this period of the year. So demand for toys can be said to be stable in the first 3 quarters of the year, but to experience a seasonal upswing in the fourth quarter at the wholesale levels, seasonal fluctuations occurs with an advance of about a quarter. Sometimes for different types of products, a seasonal factor, for example, could be on summer period, it could be 3 months period, quarter of the year. because, for example, it is about cold drinks and ice cream, for example, it is more popular in hot period of the year. In different countries, it could be different periods, and sometimes, for example, hot drinks is more popular in winter period, in cold period. So we also would discuss about it that it is seasonal factor, and we need to calculate our prognostication with this factor. So the temporary trend is determined by the long-term dynamics of the sales value. The direction of the dynamics of the sales volume can change repeatedly during the life cycle of the product. For example, as a result of changing customer preferences and tastes, a possible trend in the purchase of PCs in the 21st century change on a natural one, for example, reorientation towards laptops and tablets, when we change our personal computers for some more compact gadgets, and we could use our mobile phone, for example, more for everything, and we could change some documents and work with Excel tables and something else. So it really was a period when demand of different types of gadget was bigger and bigger, and demand on personal computers less and less. So yes, when making forecast, it is important to know which of these factors affect the change in sales value. For example, a decrease in the birth rate means a subsequent decrease in the demand for disposable repairs. So, the cyclist factor, this next factor, manifests itself in a change in the amount of demand with a periodicity and since 1 year. For example, the demand for housing as well as the accompanying demand for basic household goods is related to the business cycle. So we also think and no, not only think, we calculate everything and has some graphics and some meaning of different position and planning for future, what we need, how in which type of goods we need and when we need, because it is about location, it is important factors. In the sale promotion effect, perfect changing in demand in response to making activities, promotional presentation, sales with discount, for example, offering free trial products, etc. Such change are often characterized by a rise in demand immediately during the advantage campaign and a drop in demand after it ends. In some industries, adventures sale account for 50 to 80% of annual sales. Sometimes it works, and we know that market programs, of course, used different types of activity, different sales, different proposition, and sometimes it is really good for customers and really good for shops to use it and to realize all goods, for example, for some periods when it is really actual and when it could be buy in this shop in this period of time, period of the year. A random factor, we also has such type of factor, random factor, because sometimes we couldn't understand why customers couldn't buy this product, because we already prepare everything, we calculated everything, we propose different discount and different programs, marketing and everything, but sometimes we have a random factor is those random or unexpected change in demand that cannot be explained by other factors. The more precisely and completely all other factors are taken into account, the less the influence of a random factor. So sometimes we could have such result not very good, or sometimes very good, because a random factor could be for very high demand on this type of products, and you couldn't propose so much goods, for example, shoes or mobile phones sometimes, and it could be not very good because we have a big part of customers, and we could prepare for them. So, continue, and our next question is about forecasting process. The forecast horizon in logistics usually doesn't extend beyond 1 year. In practice, monthly forecasts are most often used because during 1 year we could, for example, calculate something for 1 year for our company for planning our work. But every month will be better that we recalculate it each and change something which is something with some information which we know for this period of time, and for example prognostic to next month. First, the foundation of the forecasting process is a database containing information about current orders, past orders, and methods of attraction these orders, which include promotional discounts, special discounts, or other sales promotion methods. So sometimes it is really important. Second, an effective forecasting process must generate integrated, internally agreed forecasts that meet the needs of users, for example, finance, marketing, sales, production, and logistics. Due to the very nature of each task, the distribution channel must be sensitive to market demands. We also discuss about sensitive to market demands because different type of products could be produced different manufacturers. For example, the shoes, shoes could be produced different companies, and customers could choose what they need, what type of shoes, and for example, what quality, what price, which price, and other. So it is really sometimes we could prepare everything, good market, good quality, good shop location, and other, but sometimes, for example, sensitive to market demand could change everything. So it could be a random factor and other, because we have different types of manufacturers that could produce the same type of products. So if we had the same type of products, we could to prepare and be careful in this position. The system is always ready to start the logistics process as soon as it received a signal about the branches of a need. It is necessary to treat with all diligence a regional organization of a reliable system of information exchange, while maintaining its flexibility necessary for successful adaptation to changes. So sometimes it is really very important adaptation to changing and recalculated some information about it. Also, we sometimes discuss and think about how we could prognose and the information will be very good calculated, and if we find more factors which could change our demands on our products, it will be better because we could prepare it more carefully, and we had to prognose more actual. For this period of time when we used different types of gadgets, when we use different types of programs and with IE also, we could had more actual prognosis. And for this period of time, the result of prognosis information will be near 99%. It is very difficult because we have only 1% change. It is not really sometimes, but we try to have such prognosis information. So it is really important for every company, not only for transport company. It is for local shop, for example, levels which we discuss today in our lectures. It is important for local shop. It is important for other systems. So sometimes it is such. Okay, stop sharing. We discuss all this information that I prepare for you on today about prognosis in supply chains.